All right, so you guys, I did ask you to make sure those graphs were done. How's page 8 looking? That's where I wanted you to start, page 8. Did we finish those up?
Yes.
I am not checking those as homework because it wasn't even supposed to be homework. Wait, am I recording? I am, okay. Those were not supposed to be homework. We were supposed to finish those in class. A lot of us did. So I just want to talk about the graphs a little bit on page 8. Hopefully, yours should look somewhat like mine. Up and down. The plant A and plant B were different. Blakely, yours looks different than mine. Why? Trinity's looks different. Caden's looks different. No, Caden's different. Yours is different. Why is everybody's different?
Maybe because they use different numbers.
Oh, wait, yeah,
different numbers.
Different numbers. I'm just going to speed up Blakely's because it's way up front here. I went up by 2s. Every line equaled 2. Blakely went up by, looks like you counted by 5s, but you went 1, 2, 3, 1, 2, 3, the fourth one's 5. 1, 2, 3, oh. Sorry, I didn't mean to use cadence because it's not right. Yours is also different. Okay, sorry, Blakely, not a huge deal though. Ooh, okay, this is another one. It looks like Caden went up by 2.
I did.
But I also went up by 2.
But I skipped a line.
But Caden skipped a line. Don't steal my thunder, dude. That's what I wanted to say. So this is one of the exact things I wanted to point out. Now, I went up by 2s, but I went every line. Caden went up by 2s, but she skipped a line. So as Aiden mentioned, right, Aiden? As Aiden mentioned, it's really like going up by 1. Even though you skipped a line and went by 2, so that what's this line equal? That's 1. Caden, if this was a Regents, I would have to mark you wrong because you're not allowed to make another line that doesn't exist on the graph. Okay, it's fine for this. And it ended up working out really nicely because it was only 1 extra line. But if it was the Regents, you can't do that. Okay. Did anybody else go up by 5s at all? How about yours?
Oh, sure. I didn't use 1 out of 1.
That's good. I'm really just looking at the scale. So in this case, we went up by 5s. 1, 2, 3. The fourth one's 5. 1, 2, 3. The fourth one's 10. 1, 2, 3. The fourth one's. Yeah, she just counted a little better than you. That's all. Just be careful. If it was a real Regents, I'm sure you would have taken your time more and you would have counted correctly. Yeah. I'm not judging. Everybody counts wrong every once in a while. Guys, okay, stay with me though. So there's a reason I want to point this out. So in this case, though, where the heck is 1? Did you struggle with that? Yeah, and that is one of the struggles I don't want you to do. This is not wrong as long as you estimated, like, didn't we need 1 for one of them? Oh. Yeah, so going up by 1s, in fact, I'm not super good at where 1 is on this, because that's like fractions and stuff. So I would avoid this at all costs because I don't want to make your life harder. Go up by ones that make sense completely. So yes, your counting made perfect sense, but then when you went to go to estimate, it makes it really difficult. So if you were doing 5s, I would have stuck with going every single line was 5, 10, 15, 20. That way you can kind of estimate a little bit easier. If you do this, you just have to make sure your estimating is really good. Now, here's the other thing. I put up my graph and I said, do yours look like mine? And a whole bunch of you were like, mine doesn't look like yours. So Caden's really doesn't look like mine at all. I think if I put them down here, we might be able to see both of them. I knew that was going to happen. All right. See if it works. All right. I need to go a little farther. I knew it was going to just connect. I hate technology these days. Okay. These graphs are the exact same numbers. Katie just spread hers out more. If this, you see a big, big difference. Which one looks more dramatic to you? Mine? So I guess it depends on what you mean by dramatic. Like to mine, that change looks really great, doesn't it? Like mine goes, it jumps that high really quickly. Kate is that, it's the same idea, it still jumps, but it looks like it takes a lot longer for that jump to happen. This is why graphing and making your scales look nice is important, because this is actually, so I'm gonna give you a little public service announcement. Let's say this was something that they wanted to talk about in the presidential debate, whatever, these plant bubbles and depth, and they're like, it's really important, this depth and plant bubble stuff. So clearly they're not talking about it in the presidential debate, but imagine they were. Which one do you think you'd be like, if you saw this, wouldn't you be like, oh my gosh, look at that change? If you saw this one, you'd be like, it's changing, but look how long it's taking for that change to happen. People can manipulate the way stuff looks by changing the way they graph it. Same data, but could give you a different idea about what's going on. And this is why I like to say, this class is not just about teaching you science, it's also about making you think a little bit. You need to think on your own. Anytime you're given information, especially with this election year coming up, we know, and by the way, I'm not getting political, I'm not telling you to vote one way or the other. I'm telling you, when anyone's giving you information, you need to look at it and decide what it's actually trying to tell you. Because these graphs are literally the exact same data, but give off different ideas by just looking at them. So always pay careful attention to who's giving you data and how they want you to make it look, because this can be, if they wanted you to vote one way, they could say, wow, look at that one, or that one's not a big deal. And so they could show you a different graph depending on how they want to manipulate you. So just be careful. All right, so graphing is important. By the way, both, other than the fact that Kate went off the graph, both are correct. Same with this one, also correct, even though all three look different. All right, that one's, I can look you up, yeah. Give me a minute. Or are you like hemorrhaging out?
No,
okay.
I can.
All right, good. All right, so we're gonna switch up to page 9. Yay, it didn't turn up. No. It might look like geometry. Please don't get freaked out. Anytime you see something that looks like math in this class, please don't. Okay, don't get stressed out about math in this class. Any math we do in this class will be very basic math. In this case, it's still basic graphs, which I know is mathy, but this is not the stuff you do in math. This is way, way easier. So we're going to be interpreting graphs. Let me take a step back. This year, you have to be able to make a graph. You have to be able to label it correctly, plot it correctly. That's the first thing you have to do with graphs. The second thing they're going to make you do is what we call interpreting graphs. What's an interpreter, or what is interpret mean? Often we use it like a sign language interpreter. What does a sign language interpreter do? Helps you understand it. Another word might be to translate. So if one of you needed me to sign, I don't know how to sign. So they would give me a sign language interpreter, somebody who does know how to sign. I would speak words, they would sign it for whoever needed it. And then vice versa. If you wanted to talk to me, they would take your sign language and put it into spoken words for me. Interpreting a graph is similar. It's basically translating a picture, a graph, into spoken or written words. It's just taking what the graph is saying in a picture and putting it in words. Graphs don't always have to have numbers. The graphs we did had numbers, obviously, but now we're going to be able to be given a graph like this one. And you need to tell me what's going on. Anybody want to take a stab at it with the A and B there? Could you interpret that? Could you read that graph? I know it does tell you the answers, but could you tell me what's going on that graph?
A goes up.
Not quite. It is an increasing graph. How do you know it was increasing? Okay, so it has something to do with increasing.
As A rises, right?
Almost.
As B rises, A rises.
As B rises, A rises. That's the way we have to take this. And that's because what variable goes on the x-axis? The independent. The one you're changing is the one that's on the X. So that's the one that you got to talk about first. The one that you're in charge of, you can talk about that one first. So if we were looking at those plant bubbles, at least for here, this first part, as depth increased, there were more bubbles. Now here, as depth increased, there were less bubbles. So this one's not quite as straightforward as these ones that are nice and straight lines. There's a system for this, and the system makes it pretty easy. So if you just read through this, it says when interpreting a graph, read the bottom variable first. This is your independent variable. Then read the side variable and describe what the graph or the line in the center of the graph is doing. For example, over here it says as B increases, A increases. So let's talk this through. If I was to give you this graph and I labeled it studying and grade, if I was here, how much studying are you doing? What? I think none or very, very little. If you were over here, how much studying were you doing? A lot. The x-axis always increases, no matter what. So this temperature graph, this time, temperature, volume, and time down here, the x-axis is always increasing. Even if it's not numbered, you can assume the x-axis is always increasing. So to do this, I kind of have a system. You have blank space right here. You ready to write my system? You will always read these by starting off with as, and the blank is going to be the x-axis. So as the x-axis increases, then the next thing you're going to look at is the y-axis. And then you're going to do what I call read the line. If you do it that way, as x-axis increases, y-axis, then tell me what the line is doing. For example, here, as B increases, A increases because the line is going up. Let's take a look at this one, temperature and pressure. As temperature increases, because the x-axis always increases. Pressure, just flat out read the y-axis. What's this line doing? That's an increase. So as you increase the temperature on an experiment, the pressure will also increase. How's that next one look? We need to write that one out completely. As time increases, because you read the x and it's always increasing, then you read the y, that's temperature. And because that's a flat line, temperature doesn't change, so stays the same. So this is just showing quick relationships. So in this experiment, as time went on, temperature stayed the same. The rest of that page is homework. Then this page, so page 10, the back, we are going to go the reverse way. So now I give it to you in English, and you have to draw me a graph. When drawing graphs, you do need to label the x and y axis. So in this case, we have as depth increases, pressure increases. Which one goes on the y? Or I'm sorry, which one goes on the x? Depth. That leaves pressure over here. And then how do I draw an increasing line? It's an up line. So by the way, in case you're not sure how to tell which way is an increasing or decreasing line, if you were to walk on this like you were reading, so from left to right, you'd be walking uphill. You have to finish page 9 and 10 for homework. Easy enough? Mm-hmm. Okay. So I want to do one more thing before I give you the quiz. And that's the last new stuff before we get to density. We're on page 11, and this is rate of change. What does rate mean to you? Like if I ask you what's your heart rate, what's that asking you about? how fast your heart's beating per minute. If I asked you the rate at which you grew last year or in the past 10 years, what would that be asking you about?
Or how tall is that?
How tall you got over a period of time, which is another word. Is there an easier way of saying that? How fast you grew? If I asked the rate that the temperature rose this morning, what would I be asking about? How quickly the temperature changed. Rate of change is really just how fast a change happens. And now I'm asking you for a formula. Don't freak out, formula equals math, yes. But in this class, what did I tell you about formulas?
They're all in the reference.
They're all in your reference tables, that yellow packet. I would like you guys to grab it. It's hint, all equations are on the front cover. Go ahead and write in the equation in this box. On the front cover. The rate of change equals everybody find it in your reference table? I'll show you in case you didn't. So here is, yes, I have a purple one, you have yellow. All equations are written right here. Rate of change is right there. So fill that in that box. So it's change in value. Change in value divided by time. They keep it like generic or basic there. So they don't say change in height. They don't say change in temperature because it's a change in whatever you're measuring. So it could be height. It could be temperature. It could be distance. It could be weight. It could be number of bubbles for that other one or number of sunspots for your lab. So rate of change is just how much whatever you're measuring changes over time. And on the graph, if we graph this, it helps us, makes relationship easier to see. For example, if we have a steep slope on a graph, what does that tell you about the rate of change? If it's steep.
That's like a dramatic increase.
Dramatic or increasing fast, yes. So that's a fast change. What's a gentle slope on a graph?
A slow change.
That's a slow change. And what's a flat line on a graph?
No change.
So I don't know if it was last year or this year from math that you guys did rate of change is X over Y or something like that. That works if you have a beautiful graph. This formula works if you don't even have a graph at all. So if you're just given a statement that says the rate of snowfall or it snowed 10 inches in the last hour, you'd be able to tell me the rate of change is 10 inches per minute or hour. Sorry. That's all I wanted to do for today. You have you do have 9 and 10 for homework. What I'm going to do now is give you out your quiz. And you have the whole period or the whole rest of the period. How I work quizzes and tests is if you need more time, I'll give you more time. I am not concerned. I don't sometimes want to use the whole period. So that way, if you do need to finish on your own, you can, but I will never give you a time limit. I do this because on the Regents, you guys will get 3 hours. I have only once had a student run out of time. It did turn out that person, they never told me this, but English was not their first language. And what this kid did is he would read the question in English, translate it into, I think he spoke Spanish, but it might have been, doesn't matter, not important. But he would translate it in his head, answer it in his head in Spanish, and then translate it into English on his paper. That takes a lot of time. And honestly, if he had told me that's what he did, I would have actually been able to give him extra time on the test. New York State says, if English is not your first language, you automatically get extra time on the region. Or I could have given the darn test to him in Spanish, and he probably would have aced it. So if that, by the way, applies to any of you, you get more time on tests, but you can't tell me the day of the regions. You have to make sure we know that ahead of time. So anyway, the reason I'm telling you this story is you will have plenty of time to take the regions. And I want you just to get used to taking your time taking a test. So if you need more time, let me know. On this, there are 7 statements. You have to tell me, are they observation, inference, or prediction? Then there are 5 regions questions that you have to read carefully. Once you guys all get one, I just want to talk about those statements for a second. You know what? Here. Very creative for you guys. So for these statements, I want you to, like for the second one, it says the dog is hungry. And the 6th one, it says the dog is growling. Imagine there is a dog right here, okay? There is a dog right here. Now you can't see it in real life, but pretend there is. Okay, so you are in the room with the dog. For number 4, it says the classroom next door is having fun. Imagine you are sitting in my room and you are making this statement about Mr. Job's room next door. Okay, but follow the rules we did for observation, inference, prediction. For the pebble, there's a pebble in my room. You have anything you need in my room to tell me if that's an observation, inference, or prediction. And again, the liquid is white in color. Imagine there is a jar of liquid right here, and you can, yeah, that's all I'm saying. There's a jar of white liquid. Okay, observation, inference, prediction. That's it. Read carefully. When you are done, bring it up, and then work on your homework. And that's all I'm doing for today.